So this says solving, what is that we're solving? What does this little thing right here mean? This, you see this little 3 right there? That's called an index. If the index is a 3, this is called a cube root. So this is called a cubed root. To help us understand cubed root, stop a minute and think about what a square root means. So in this space right here, what is 4 squared? Of course, that means 4 times 4. What's that equal to? Then what is the square root of 16? Well, it's 4, because the square and the square root are opposites to each other. This is 4 because 4 times 4 is 16. That's what the square root asks. What number got multiplied by itself? Well, let's take that and apply the third power to it. What does 4 to the third power mean? 4 times 4 times 4. So what is 4 times 4 times 4? And if you're putting it in your calculator, the button to raise it to the power looks like this, and it is on the left-hand side of your calculator about halfway down. And so that's how you would put it in the calculator. So what the root means with a 3 right there is what number got multiplied by itself 3 times in order to get that 64 number. And so the answer to that is 4. The cube and the cubed root are opposites to each other. And just like before, what's the first word in our first step? Isolate. And so it's really going to be just about the same steps. So the first word is to isolate. That means this needs to be by itself on one side of the equal sign. Is the radical by itself on one side of the equal sign? On this problem it is. So then what is the next step? Raise it. This time we're not going to raise it to the second power. This time we're going to raise it to the third power because this little 3 right here. And the 3's cancel each other out, and this is 5x minus 1. We just did this. What's 4 times 4 times 4? 64. Add 1 to both sides. 5x equals 65. And what do we do with the 5? And x equals 13. Right? 13? Now, back over here, it says check your answers. Checking your answers is always a good idea, but it's not actually required like it is on the second power. When you raise something to the second power, an extraneous answer might get in there. And that has to do with the square root having a domain of 0 to infinity. It has what's called a restricted domain. And so when we square it, we get a different domain. And that's how those extraneous answers get in there. It has to do with the graphing. Help me to understand it a whole lot better. But this is what we have in the third power. The domain is negative infinity to positive infinity. There's no restrictions. All that to say, checking is nice, but it's not required when you raise something to the third power. Checking is required when you raise something to the second power. It's not required when you raise something to the third power. But We still have the same first word in our first step. What's the first word of our first step? Isolate. That means this part right here needs to be by itself. So what am I going to do with the 1? And so then we're going to have 4x minus 13 equals 3. To get rid of the third root, you raise it to the third power, and of course you do that on both sides of the equal sign to keep everything balanced. What is 3 raised to the third power? 3 times 3 times 3 is 27. What do I do next? Add the 13 to both sides of the equal sign. This step right there is where a lot of people made sign mistakes. Some people made sign mistakes because their own writing was so messy they couldn't read it. I can't help you with that. You might try to work on that a little bit. Checking is nice, but it's not required when you raise something to a third power. It's only when you raise something to an even power, like 2 or 4. The first word in the first step is isolate. This part right here needs to be by itself. So, am I going to get rid of that 2 or this second 2? Which one comes, which, so what do I do first to isolate it? So this would be 2 equals 10. Now I still need to isolate this, so I need to get rid of this 2 out in front. The 2 out in front is multiplied by the radical sign, so what's the opposite of multiply? Then to get rid of the root, the opposite is to raise it to the third power. That cancels out. Now, there is another thing I just want to mention. Same problem. You can actually cancel this 2 out first, but if you divide by 2, you must divide everything by 2. If you want to start out with a division, you can. But when you divide both sides of the equation by 2, you divide everything. And so that would cancel out. And 2 divided by 2 is 1. And so do you get to the same place? But here's the reason we don't suggest doing it that way, because most people, this part right here, that you have to divide everything, including that. But you get the same answer as long as you make sure you follow the steps correctly. Step number 1, first word, is to isolate. So in order to isolate that, what am I going to do first? Okay. Did I hear subtract 5? Now 5 subtract 5 is 0. And I put that there because some people canceled out the 5 and then they asked me, well, what do I do with the plus sign? Well, 5 subtract 5 is 0. When you add 0 to something, does it make it more or less, or it stays the same? Of course it stays the same. And so when you add 0 to something, it doesn't have any effect That's why I can leave all of that off. Now at this point, some of you see a fraction, throw down your pencil and quit. No, that is not the correct procedure for fractions. As I told you in the not the very first lesson, the second lesson we did in August was on fractions. If you have a fraction, you don't throw down your pencil, but you do try to get rid of it. You get rid of a fraction by multiplying by the denominator. What's the denominator here? And so you multiply this side by 2. If you multiply this side by 2, you got to multiply that side by 2. The reason I multiply by 2, what's half of 2? 1. The 2's cancel. So I have the numerator. Now, when this 1 out in front is multiplied. When you multiply by 1, does it make it more or less, or it stays the same? And that's why we usually don't write it down if we have a multiply by 1. Now we're ready to get rid of the radical sign. The radical and the 3 cancel each other out. Subtract 3 from both sides, and x equals 261. Checking is nice, but it's not required when you're raising something to the 3rd power. And this worksheet that I'm about to give you is due tomorrow. And many of you will be able to finish it in class today.